landed at 877 words, within the 900 plus or minus 5% target. Here's the final script. Right now, WR-104 is still aiming its collapsing core toward Earth, and astronomers at Caltech have no way to stop it. 8,000 light-years away, a dying star is pointed almost directly at us. Right now. Not in 1,000 years, now. And when it finally collapses, it may fire a beam of pure radiation straight down the barrel, straight at our solar system. Nobody knows exactly when. Nobody can look away from it either. But here's what nobody is telling you about what's actually spinning inside that spiral of dust. WR-104 is a Wolf-Rayet star, a dying giant burning so hot and so fast it's shedding its own outer layers into space, 100,000 times brighter than our sun. It sits locked in orbit with a smaller companion star, and together they carve a slow, glowing spiral into the dust around them, like a pinwheel frozen in a photograph. Astronomers first spotted that spiral in 1999. It looked beautiful. Then they looked closer. The spiral wasn't just pretty, it was a clock. Every turn of that pinwheel marks the star's rotation, and that rotation revealed something they didn't expect. The axis of this dying star's spin appears to line up almost perfectly with Earth. Here's the part that changed everything. Wolf-Rayet stars like WR-104 don't just die quietly. When a star this massive collapses, it can trigger a hypernova, an explosion violent enough to punch two narrow beams of gamma radiation out through its poles, in opposite directions, like a cosmic spotlight switching on for a few seconds. If Earth happens to sit inside that beam's path, the radiation could strip away our atmosphere's ozone layer in moments. Not years, moments. And the geometry of that spiral, the exact angle astronomers measured, puts us within roughly 16 degrees of the beam's line of fire. Close, uncomfortably close. So Caltech researchers did what scientists do. They tried to rule it out. They ran the models again. They checked the tilt, checked the distance, checked the timeline for when a star like this actually explodes. And every version of the math came back the same unsettling way, inconclusive. They can't confirm we're in the beam. They can't rule it out either. Some astronomers argue the odds are still low, that the geometry probably isn't exact enough to matter. But probably isn't a word you want attached to a gamma-ray burst. And nobody, not Caltech, not Harvard, not a single observatory on Earth, can tell you the one number that actually matters. When? That's the part they're afraid to say out loud. WR-104 could already be dead. Light takes 8,000 years to reach us, which means the explosion, if it's already happened, is already on its way, already crossing the dark between us and it, and there would be no warning shot before it arrives. No dimming, no signal. Just years of silence, and then a burst of gamma radiation slamming into our atmosphere before anyone could say a word. Some researchers estimate WR-104 has somewhere between a few 100,000 and a few million years left before it collapses on its own timeline. But that estimate assumes the star behaves the way models predict. Wolf-Rayet stars are famous for not doing that. They shed mass unevenly. They flare. They destabilize early. And here's the strange part. The very features that make WR-104 so mesmerizing to photograph, that elegant spinning spiral, are the same features that prove its axis keeps drifting slightly over time, which means even the 16-degree estimate isn't fixed. It's moving, slowly, unpredictably, toward us or away from us, take your pick, because right now nobody actually knows which. And nobody at Caltech or anywhere else has a way to pin that drift down for certain. That's not a footnote, that's the whole problem. If WR-104 is aimed at Earth, the implications reach far past one star. It means our entire understanding of cosmic safety, the comfortable idea that dangerous objects are always distant, always slow, always visible coming, collapses. A gamma-ray burst doesn't announce itself. It doesn't get brighter first. It simply arrives, already finished, the light of its own warning traveling at the exact same speed as its own killing blow. Scientists now believe bursts like this may have already reshaped life on Earth once before, in a mass extinction millions of years ago, long before anyone was watching the sky. WR-104 would just be the next one already aimed and waiting its turn. A loaded gun 8,000 years down the barrel, and we are standing in the only place we can stand. So the question isn't really whether WR-104 will explode. It will. Every star like it eventually does. The question is whether it already has, and whether the beam is already crossing 8,000 light-years of empty dark, closing in on us at the speed of light itself, with absolutely no way for anyone on Earth to see it coming before it's already here. What would you do if you knew the countdown had already started? Tell us in the comments.